And one.
I remember to start recording.
Good job. Cool. And I'm sure you can all see the first slide. We good?
Yep, we can.
Yep, good.
So, yep, I'm Tony Ramirez from Now Secure, and I'm going to give Corey just a little chance to tell you a little bit about Now Secure.
Yeah, so I thought it would be helpful for those that may not have ever heard of Now Secure to give you a little bit of insight into who we are and what we do. Now Secure is a pure play mobile application security testing company. Essentially, we help very large organizations, as you can see on the left here, in the financial space, retail, healthcare, federal government, you name it. We help them ensure the security and privacy of mobile applications that they build, as well as mobile applications that they consume as a business. So third-party apps they may be using across the business to drive productivity. Essentially, when it comes down to it, we help understand and provide visibility into the security and privacy of any mobile application at any stage of its life cycle, from any source. And what I mean by source is could be integrated into a development life cycle. It could come from the iOS or Android app stores. Any app that runs on a mobile device, we can test it for security and privacy concerns and then provide feedback to both security and development teams to make smart decisions and prioritize how to remediate those issues and deliver awesome, secure applications to their customers. We actually started about 10 years ago as a forensics company. We were performing forensic analysis against mobile applications in some high-profile legal cases, as well as pen testing mobile applications for some of the largest banks in the U.S., who were kind of early adopters when you think of, the initial business to consumer mobile applications. And they've obviously got some regulatory standards to meet up to. So we eventually started building some software products to automate the process of building and securing mobile applications. So we've been able to help hundreds and hundreds of organizations automate the process of testing iOS and Android apps, understanding what the risk is and what to do about it. There's some really interesting open source projects out there that folks from the Now Secure research team created and maintain. So those namely being Frida and Radare. So those two tools used for reverse engineering and hooking into an application at runtime to interact with that application. I'm sure some of the more security-minded folks may have heard of these technologies. The folks that created and maintain those projects work for Now Secure, and it's a fundamental part of our strategy. So we collaborate and share back to the open source community very frequently. The last piece is, we're a big part of OWASP. Tony's probably speaking at roughly 15 to 20 OWASP groups in a year. That might be an understatement there, but we actually helped create and sponsored the mobile security testing guide that OWASP had put out, right? So if you think about OWASP top 10 for web application security, a few years ago, they created the mobile top 10. And in recent years, they've created the MASVS, which the acronym escapes me. Tony will know, but the MSTG, Mobile Security Testing Guide, which are specific guidelines and parameters for how to address mobile security testing and what to do about mobile security issues. So we're a big part of the OWASP community, and we're very excited to have the opportunity to chat with you guys today. I'll pass it over to you, Tony. I don't know if you had anything else to add as we get going.
Yeah, no, I think that's really it. The only thing I'll say is one of the great things about Now Secure is our research team. We have an amazing cutting edge group who are just creating these awesome open source tools. And if you're not familiar with Frida and Radare, check them out. That if there's one thing you walk away and you're thinking, oh, like security testing, I know a little bit about it. I should probably I'm trying to figure out all the tool sets. Check out Frida and Radar. They're very cool tools. They're very widely used by the open source community and are totally just powerful tools. But yeah, let's get into things. Yeah. So I'm Tony Ramirez, Senior Application Security Analyst at Now Secure. I've been at Now Secure for coming up to 4 years as of, I think, next week, which is crazy. But in general, me, I love cooking. I play guitar. I like bike riding. I got into bike riding during COVID. And, I'm into security. And, for me, security means, testing mobile apps, helping organizations figure out, coding standards, even doing some IoT testing, because a big part of mobile now is IoT. And, just kind of being the helpful person for a lot of organizations and figuring out these challenges. And, mobile is not as small as it was when I first got into it. When I first got into mobile, I was in grad school and I was doing research on how applications could protect themselves against certain types of scenarios and all these things. And back then, mobile was just this kind of thing that was first starting to take off. You really didn't have a lot of mobile apps yet. A lot of organizations were still figuring it out. And there's this quote by Steve Jobs that I always think is kind of silly when I first heard it, but it kind of ended up being true. And it's this thought that, we're moving away from being a PC society and being more of a, mobile device society, that everything is in our hands now, that there really isn't a good reason for most people to have desktops anymore. We're kind of entering this phase of, I have a desktop when you can just have it in the mobile app and carry it in your pocket. And he was kind of poking fun at the idea of going from pickup trucks to cars. And, it is a really great analogy, because when we look at how much time people are spending using mobile apps, using mobile devices, tablets, and smartphones, it's obvious that kind of desktop is waning away. It's not going to go away for everyone, but for a lot of people, it's not going to be the primary way that people get connected. Mobile apps are now the primary way people get connected. But with that comes challenges. Let's be real. When web applications first started taking off, people started who were, a little bit more malicious than, the people in this group, probably started thinking, well, maybe that's the thing to go after. And mobile's starting to become that new thing where, before, somebody would target your web application. And now they're saying, well, the web application practices that these organizations are using are really strong, well-tested, and well-established. While in mobile, they're not. And a lot of organizations are seeing that they're having all these issues. And I'll tell you this, in the last 3 years, 4 years ago when I first started Now Secure, you might hear about a breach maybe once a month, maybe once every 2 months. Now it's common to see multiple breaches per week, multiple issues per week. One that's not on here, the TikTok thing. A lot of national governments are really requiring people to crack down on the apps that they can have on their devices, because it isn't just security issues now, it's also privacy issues, and how types of data are being handled by the applications could end up leaking and causing issues beyond the scope of what you think your app has access to. And to kind of go on that, because I think a lot of you are developers, you work with developers, the common challenge that don't get me wrong, I used to write code, and I used to copy paste stuff from Stack Overflow all the time. And the truth is that that's really bad. As it turns out that they did an analysis. We were working with a university, and they shared this statistic with me, and I thought it was just the greatest thing ever, because what we found out was, they did this big analysis on a bunch of Android apps in 2017, and they found that about 97% of the Stack Overflow code that they were using was insecure, and about 15% of those apps actually had copy-paste code in them. That's crazy. That's crazy. That means that most Stack Overflow code that's being used for mobile apps, it has some security flaw in it. It's just crazy. But here's the thing. It's not that anybody actively goes out to create bad apps. I think that that's unrealistic. I think that's like a security analyst idea that, oh, they're just making bad apps to make my job harder. But the truth is writing apps isn't easy. There's a lot of things that go into play, and there's a lot of bugs. There's a lot of like issues in the App Store, and they aren't just security issues. They're privacy issues too. There's a lot of just unawareness around what's going on in mobile. And it kind of makes the idea of what a security bug is and what you have to do to prevent it this abstract concept. And we're going to kind of break that down right now. We're going to address that. We're going to look into that. And I think it really starts off with this concept that everyone has when they start talking about mobile, and it's like, what's better, mobile, Android or iOS? iPad and iOS versus Android, and which one's more secure? And I think if you want to post your idea of which one's better, go ahead, post it in the chat, because I'll tell you there's not a wrong answer, because it's a little bit more complicated than that today. It's really way more complicated than that today. I used to ask this question before I would even jump in to a chat. I'd go like, who here is a mobile developer? And you would get like, a couple hands up, a couple like, I've tampered with it, I've played around with it. But the truth is that more people are mobile developers and they don't even realize it. It's crazy because there's so many frameworks being developed. There's so much going on right now to make mobile easier for people who are writing code in different languages. I think, Gina, you mentioned that you're getting into C#. And guess what? You're a mobile developer, because guess what Xamarin apps are? They're C# apps. So you're a mobile developer. That's cool. If you write JavaScript, guess what? React Native is JavaScript. You're a mobile developer. You write Java, then you probably know how to write Kotlin too. And both of those are mobile development frameworks. C, C#, C++, mobile developer. Objective-C, Swift, doesn't matter. A lot of people are mobile developers and they don't even realize it. But here's the thing. All of these tools, and this is the one that everyone always asks me, like, okay, so like which of them is the best and which one is the worst and which one's not secure and which one is secure? Doesn't matter. They're just tools. Every one of them is capable of writing a secure app. Every one of them is being used insecurely on the App Store today too. And there are major organizations that are using these tools to write great apps. So it really comes down to what the developer's doing and what practices they're following and how they're writing this code, and just being aware of what they should be aware of. And that's realistically the real challenge. And it kind of comes down to what is the actual scope of mobile app security? Because a lot of people will come to you and they'll say like, oh, I don't really get like what we're actually talking about. Like, are we talking about like, is the phone secure? Like, what's going on the device? Like, is the device a part of this, scope of security testing? And, when you look at the ecosystem of mobile, you start thinking, well, you have this app and you have the OS and you have the device and you have the cloud and you have the backend and you have all these components. So which part of that is actually like mobile security? Is just one part of it? Is the device part of that? The reality is when we start getting into actual like mobile app security testing, we're really talking about the app and not the device. Because really, as a developer, you only really have control over what's in the app and what the app does. So you have to consider that when you're actually thinking about what the app's, attack surface is and what's actually going on in your threat model. And, again, like people who come into the space, their first thought is like, well, I'm just going to hack the device. I'm going to set up a Raspberry Pi or something. And it's like, well, it might be even simpler than that. And it's a little different than that. But the truth is device testing, app testing, you have different goals, different skills. And the truth is you have very little control over a lot of these things as an app developer. And the first one that comes to mind is what device actually installs the app. You really publish your app out into the App Store, and once it's out there, any device that's compatible can install it. And that might be an old device. That might be a device that never gets updates. That might be a device that's been compromised in some way or compromised on purpose. And, there's various other problems that come into play because, not all the OEMs are the same and not all the hardware is the same. It used to be that if you had an iOS device, they were all pretty equal in terms of security, but now that's not really true anymore. iOS has a bunch of problems because like older devices now are really easy to jailbreak now. Like it's ridiculously easy to jailbreak older models of iOS devices. And unfortunately, those are the really common ones because those devices last really long. So, you know, that's one of those challenges that you as an app developer have no control over. But what about the other apps on the device? You know, you consider that, you know, your app is running on there, but you know, you can't really control what other apps are being installed on that device. And one of the examples that come to mind, everyone thinks about malware, but malware really isn't as big a problem in the app stores as people think. Google releases their statistics about it. Android releases their yearly statistics, and it always ends up being somewhere around like, you know, maybe 1 to 2% of like global users actually have installed malware on their device. It's even less than that, I think, now. But there are, and the other end of that too is, I'm not gonna like lie, iOS does not, Apple, or iOS, Apple does not publish those statistics, so we don't know on their side. But the reality is that the apps that are really scary on your device are the ones that aren't malware. They're the ones that are actively collecting data and telling users, hey, you know, if you let me install this profile on your device or this VPN, you know, I'll send you a $5 gift card every month. And, you know, you get a $5 gift card. You just have to make sure this thing is running. And that's the truth. A lot of malicious VPN apps are out there. A lot of market data apps are out there. And they're literally just there to collect data. And, you know, they might be collecting your app's data. They might be collecting information about your users. And, you know, your users are consenting to that. And sometimes that's stuff that you're not consenting to as a developer. It's stuff that you don't want seeing being collected from your app. Another one, and this is the common one, is, you know, where your device is connecting. You know, everybody who works in security has this idea of like, oh, I'm going to connect, like our users are going to connect to the, like, you know, coffee house Wi-Fi, and that's it. You know, we're doomed. Once they connect to that, it's like, you know, it's game over, because who knows what else is on that Wi-Fi. But I think in mobile, it's actually getting a little bit more complex, because it used to be just, you know, like the network, but now you have all these like dangerous peripherals, and there's a lot of smart people creating really cool tools out there to, you know, break devices. Last Black Hat, somebody was showing off this USB charger they created that if a device connected into it, it would automatically root or jailbreak their device based on what operating system it was on. And then it would set up a VPN that could just collect data right off that. So it would act as a little hotspot. And they were showing like, oh, we could fit that all into one of those little Apple chargers, you know, make it look really, you know, inconspicuous. And when you start thinking about, well, like that's just one example, but think about this, like how many places are there free charging stations at? I mean, when you would go to the airport, you would see those free charging stations. Every year I go to the Chicago Auto Show, and almost at every booth are these booths with charging stations at everyone. And you always see people plugging in and just walking away from their phone and leaving it there like it's nothing. And, you know, those are dangerous things. And you really, as a developer, have no control over the device or the user who's going to do that. And then, you know, Corey's favorite one are the users of the devices. You know, who's using that device? You really can't control that. You know, it could be somebody who's, you know, going to try to reverse engineer the app, trying to make sense of it. You know, you might have somebody who's a legitimate criminal who really wants to break things and really wants to hurt an organization. My favorite one are like curious kids who, you know, because there's so many gaming apps, you know, I'm willing to bet there are a lot of great hackers coming out of people who are playing mobile app games right now because they're trying to, you know, kind of break the system and get free loot boxes and all that. And you probably have all these kids out there hacking mobile app games, just trying to bypass those controls to get more free loot boxes. And, you know, they're probably using your app. And then, of course, you have, you know, the unsuspecting user who, you know, might be doing all these things, not updating their device, connecting to the coffee Wi-Fi, you know, using an old phone, and you know, installing the app that gives them a $5 Starbucks gift card every month if they keep it on their device. And they're, you know, they're kind of running the whole entire gambit. And the truth is that these are all things you have no control over as a developer. But that's not to say that you have no control. There are things you do have control over. And when we start breaking those things down, we see that, you know, you have control over that app's code and what actually ends up on the device. You have control over what data is actually written to the device by the app. And you have control over what's actually sent over the network and how it's sent over the network. And those are important things because you can develop a secure app with those things. But when they're not, you know, you have the possibility of an attacker taking advantage of that, of taking advantage of the network connectivity, of the device, of how that app runs on the device. And not only that, but the backend services. So when we start looking at what that attack surface of mobile looks like, what that scope of mobile is, we kind of break it up into 4 sections. When we start looking at the code functionalities, the data at rest, the data in motion, and the backend API. And now you have these like 4 parts. And those are the things you can control, and those are the things that you really have to protect, because those are the things that, you know, can really cause a bunch of those issues we were talking about before. But when an app is developed correctly, you know, don't have to be problems. So that kind of gets to this other point of like, how do we actually validate app security, and how do we actually verify that these things are being done correctly? And for us, it's mostly just using static and dynamic testing, the same type of testing that's used in web today. You know, looking at, you know, source code, and in this case in mobile, you know, it's actually a binary because you're putting an app out into the world. You know, you're actually giving somebody something to install on their device. So you want to make sure that, you know, that code not only is written correctly, but doesn't have any sensitive data in it. And what's great about static testing is, you know, there's no configuration, but it's less accurate. And it really does catch those bad coding practices. While dynamic testing, you know, running on a real device, you know, seeing how that app runs, you know, we're seeing some more configuration that's involved in that, but we're getting more accurate results, and we're getting way more real world scenarios. And the truth is you need both, because when we start breaking that whole concept of network testing and data at rest, and, you know, like those cryptographic practices, you know, they're easy to do on dynamic testing, but on the flip of that, code quality and like build configuration issues are really easy to test statically, but so are cryptography issues and these like platform issues. And when you have like both of those pieces together in mobile, you really end up with better results. You kind of get into that nice in between. That's really important. And, you know, getting both is important, and that's really the right way to do mobile security testing. The other end of that is understanding, like, what do you prioritize? Because we can talk about like security issues, but the truth is that not all security issues are the same. Not everything is equal in terms of weight. You know, we want to weight them correctly. And, you know, understanding what's at risk is important. Understanding that it's not just user data, but it's also privacy. It's not just, you know, the organization's reputation, but it's their property, their legal standing, you know, their business continuity. And, you know, understanding what actually sensitive data actually means, because that's a whole kind of abstract concept. Because, like I said, you're actually installing an app on someone's device. You're sending source code on a stranger's phone, and it's running there. So that means that, yeah, of course, you know, it could be violating some privacy. It could be collecting their information, but there's intellectual property there. And people tend to forget that sensitive data can be intellectual property. That intellectual property exists within your app, and, you know, it could be stolen or it could be used maliciously. So in general, when we talk about risk, one thing that's really useful for security analysts to kind of make that into a number and make that into something that's measurable is the CVSS scoring system. If you're not familiar with it, I highly recommend checking it out if you're somebody who's new into the security space, or, you know, you're a developer and you want to understand why certain issues get more priority than other. Understanding the severity of the risky issues that, you know, might be propping up in your app is going to help you kind of make better decisions. And really, that starts with understanding CVSS. So the other thing too is I think you kind of need like a list of risky behaviors. And I think that really helps you kind of establish like, what are the bad practices and what do I actually need to avoid to make my apps better? And the truth is we already have one that exists today. And that really is the OWASP Mobile Top 10. So, you know, this is, you know, an OWASP group. And everyone here is probably familiar with OWASP, but if you're not familiar with the OWASP Mobile Top 10, you know, there's the web top 10, and, you know, in 2011, OWASP said, well, you know, I think we need a mobile top 10. So they started developing it, and they wanted it to be kind of platform independent, to take in all the, you know, like different issues that are really related to mobile and really be mobile specific. So when they came down to a list, they actually had a list before in 2013, and then in 2016, they updated it again. And they're probably going to update it again in a couple years, but I think these issues still remain. The list that's there is pretty accurate. And in general, you know, you have improper platform usages, which is, you know, using platform in an incorrect way. Maybe you implement Touch ID and the Touch ID isn't implemented correctly, and it just lets anybody in. Maybe you have a data storage issue, and that data storage issue would be something like storing username and passwords in a place where other apps could access it, or communications and authentication and authorization. And in mobile, communications are a little bit more complex because those mobile communications have to be configured on the mobile app. They have to be configured client side to work server side too. So if you're going to implement these connections correctly, they have to be done client side as well correctly. And I know a lot of people here are probably cringing at the idea of, client side security, not a good thing. But on mobile, it's actually really important because if you're going to implement secure data storage, you have to implement crypto, and to implement crypto, you have to do some client side logic. Not only that, but things like code quality, code tampering, reverse engineering, all that stuff is really client side controls. And of course, the most complicated one of all is extraneous functionality, because what is a feature and what is a bug, and what is something that shouldn't be in the app, and what is something that should be in the app. And that's kind of a hand wavy concept, and that's really a hard one for a lot of organizations to wrap their head around. When we start looking at business impact, we start thinking about user data theft, we start talking about intellectual property theft, and of course fraud and reputation damage. For a lot of organizations, that's really the biggest thing, because if their application ends up on the news, then their reputation's hurt, and then somebody uninstalls the app, and that's a really big issue. I'm sure right now a lot of the CEOs at TikTok are probably saying to themselves, like, oh man, like this copy paste thing, this clipboard thing is really hitting us. People are uninstalling the app and they're not going to ever reinstall it. And maybe that's true, maybe it's not, but it brings to light that there's an issue there, and it brings to light that there's other apps that have that issue.
I will add one to that one. I was in a conversation today with the Chief Information Security Officer of the United States Postal Service, and we were running a demonstration of Now Secure Tools, and I said, do you have an app in mind you'd like to look at? He said, yes, I just made my entire immediate and extended family delete TikTok. Let's dig into TikTok. And so, the worst damage to a developer is when someone deletes the application from the phone and refuses to ever install it again. And this, CISO of the United States Postal Service says, everyone that I know, I am telling them to delete the application immediately and don't use it. And that is happening a lot, often right now. And so it does have a big impact on brand reputation.
Absolutely. Yes. Brand reputation is a huge part. And, it's never the cool one to talk about. Like, everybody wants to talk about like data theft and fraud and all these other issues, but privacy and reputation kind of are going hand in hand. And I think it's great because I think people are taking privacy a bit more seriously, and it's forcing people to think about security in a different way, because again, security and privacy are kind of left hand, right hand. They don't really know what one another are doing, but they should be working together. And it's complicated. But to kind of go back to what we were talking about and kind of get back on track, another concept that kind of is another complicated one is that web and mobile app security are completely different. And people come into the space and they try to take like these web security practices and apply them to mobile, and they don't always work because the issues are different. The security concerns are totally different. And when we look at the two top 10s, we can see, there's not a lot of overlap. There's a little bit of overlap in terms of things like, security misconfiguration is a huge broad term, but things like sensitive data exposure might kind of line up with data storage, but also kind of lines up with a bunch of other areas here. And the issues are just totally a divide. When we start breaking it down into like these core components of like the architecture of these devices versus browser, we start seeing, like I said before, a substantial amount of IP is being run on a client-side device. Web, it's all on server side. In web, you have a browser. You hope that browser is pretty secure. You hope that browser is following best practices. In mobile, like all those network calls are really up to the developer and how they're implemented in web. Like you're going to get a big red triangle that says, oh, like don't connect, or there's something going on, don't use this website. Mobile, it's up to the developer if they want to show you that. But the other thing too is like mobile's meant to kind of share data between apps, and browsers aren't meant to do that. Browser, all the content's supposed to be isolated by default, while that functionality exists and is enabled and is pretty much explicitly turned on automatically in mobile. And that really does complicate things. The amount of data that's stored on the device complicates things, and it really does mean that there are fundamental differences between web and mobile. So as a pop quiz, and just a challenge, just to see if people are listening, just out of curiosity, and you don't have to answer, nobody here has to be embarrassed. Let's just say an app has a feature in it, and that allows the organization to remotely disable HTTPS. But they want to enable, HTTP for QA testing, and that feature is in a QA or in a production version of the app. Where do you think that would fall on the OWASP Mobile top 10? Just out of curiosity, if anybody wants to take a shot. I'll give you like 3 seconds, real quick. Okay, so this is kind of a trick question because it actually kind of falls under 2 categories. So we talked about like that insecure, communications, but this is really like extraneous functionality. This is like QA functionality. Really shouldn't exist in a production app. And that's like a perfect example that, like these issues are really complicated because it isn't always just one. It could be 2. It could be more than one issue. And it could be that, really the extraneous functionality issue is what it is at the core. But that functionality created another issue, and that was a network issue. So again, now we have these like high level categories of mobile risk, and we talked about data at rest, that network data in transit, authentication, and code configuration. And just for kicks, we're going to go through one of these examples, and we're going to talk about one issue that I see a ton in mobile apps. It's an issue that a lot of organizations will come to me and they'll say, oh, I don't really get like why this is a problem. And we'll dig into that in just a second, but it goes into data in transit, because I think everybody who works in security thinks like, oh, like the network is the scariest place. The network is the wild. The network is where I have zero control and things happen and I don't know where my data's going. And, maybe that's kind of true because, depending on what protocols you're using, you might be sending stuff in clear text. You might be, sending stuff without any protection. You're supposed to be using HTTPS. You're supposed to be using TLS today because it's, the year 2020. But the reality is that that's not always true, that a lot of apps don't follow those practices. And it's really alarming because, we find that 1 in 5 Android apps is still communicating over HTTP. 1 in 7 iOS apps is still communicating over HTTP. That's a huge statistic. That is pretty much a guarantee that you have at least one app on your phone that communicates in clear text. It's crazy. But it doesn't end there, because you can implement HTTPS, but that doesn't mean it's implemented correctly. You can have vulnerable third-party libraries, you could have insecure connections, and you have all these other third-party endpoints that your app communicates to. A lot of apps are communicating to Facebook without even having anything to do with Facebook, because they have Facebook analytics endpoints, or they could be communicating to Google because they're using Google services for things, or they're using Firebase. And the truth is that there's all these other components, because mobile apps are kind of built together like Lego pieces, and people are just pulling in other pieces from other, frameworks and other things and other tools to kind of build their apps a little bit quicker. And, there's advantages there, there are disadvantages there, but, that brings in a lot of issues. And when we actually look at that type of testing, because a lot of people ask me like, well, how do you actually test that? Like, how do you actually do that? The truth is, you're testing on a real device. You set up a network environment, and you perform a man-in-the-middle attack. For those of you who don't know what the man-in-the-middle attack is, you're intercepting traffic from the device. When I do it, when I pen test mobile apps, I could be doing that, with a certain felt on the device, maybe not, maybe just collecting, just your plain text traffic. But in general, I'm using an interception proxy to do that. And we're going to go through the example. So the one I see a ton is lack of hostname verification. And in a browser, normally you would get a message if you went to a website and you had a hostname verification issue, you would get that common cert name invalid. You would go to that website and they would tell you, yeah, don't go on here. This is a bad idea. If you're going to do this, you have to click an extra like 3 buttons to actually go on this website. And this is an issue we see really commonly in mobile apps, in applications that haven't implemented the hostname verification process correctly. So, that vulnerability means that we can actually intercept HTTPS traffic, and without the user being aware, we can see what's in the requests, what's in the responses. And it's really similar to being like the use of HTTP, because in mobile, if the developer chooses not to make the user aware, they're not going to be aware about it. And it kind of adds this level of, well, I'm using HTTPS. Well, you're not using it correctly, so now you have this false sense of security, and that's almost worse than being knowingly insecure, because now you think, oh, all this time I was doing the things the right way the wrong way, or the wrong way the right way. So when we talk about that impact, again, users' data is being intercepted, that could be a breach of confidentiality integrity. Somebody could make the app run differently. They could steal that user's information. They could trick the app into going somewhere where it shouldn't go, or just reroute it. And I can tell you a bunch of stories where apps had this happen to them, and I had to explain it to the organization in a way that made them understand why it's such a big issue. And the truth is that if you have one of these issues, this is one that you want to fix right away. Hostname verification issues are really like a high priority, high CVSS score issue. So out of interest, maybe somebody here is a Java developer, and see, maybe you can see the issue in the code here. This is a common flaw we see, and this is this isn't from anybody's app, but this is something similar to what I see in a bunch of apps where they don't implement this practice correctly. And if anybody sees it, go ahead and type it in the chat. But we'll go on, because again, we're coming pretty close to the hour. So in general, I like to tell people that really good security code is actually really good error handling code. So if your application has like error handling issues, or has Boolean statements that aren't implemented correctly, it could cause security issues. So in this case, this is something we see pretty commonly. Somebody implements the hostname verifier function, but they actually overwrite the methods that are built into the platform to do them correctly. And right now, they might be just trying to get the app out, and they're just writing it up, or they're copy pasting from Stack Overflow. And what do? The Boolean function always returns true. Even if they do the verification function and it's, there's an error in there, it's always going to return true. And that's a major issue, because that means that, any HTTPS connection is going to be verified as long as that attacker, owns a CA cert. Like, they can go out, they can register a cert for evil.com, tony.com, whatever, go out and man-in-the-middle people. And that's really the way they're going to do it. They're going to buy that CA cert under their own name, and they're going to try to man-in-the-middle you. And if your application has this type of issue in it, guess what? You're going to get man-in-the-middle. So in general, when we start talking about the fix, we want to make sure that we're using the right platform functionality. We want to make sure that we're using the verify function correctly. And for every platform, this is a little bit different. Some of them make it a little bit harder. Some of them make it a little bit easier. But again, I think in general, it doesn't matter what language you're writing in or what framework you're using. You have to go with what works for you and what you have experience writing in. But you have to make sure you're doing it right. And every one of those platforms has a way to do it right. So in general, remediation is, when you establish that TLS session in the application, you want to do the server validation process. You want to actually check if it's a valid DNS name that matches the cert that you're making the connection to. We won't talk about the TLS handshake, because, we all, took Security 101 back in, whenever. But, when you do that verification process, that really is part of it, making sure that, the names match, the cert matches. And, for maybe some special connections, you might want to do certificate pinning. We won't talk about that right now, but if you're interested in it, you should reach out to me. I can give you some really interesting information about that too. But, this is a great way to prevent, confidential data from leaking. So another thing that kind of comes up is, well, I heard this and I'm hearing about a lot of the security issues, but like, how do I actually implement this in my organization? And one thing I will recommend, and Corey kind of mentioned this, was MSTG and MASVS. So here's the big, the end cap, because he was saying, I don't know what MASVS stands for. It stands for Mobile Application Verification Standard. I can say that really quickly because I've been practicing it for a few years now. Mobile Application Verification Standard. But again, if you're somebody who wants to get into security testing, I highly recommend checking out the Mobile Security Testing Guide, because it has cases for basically every single type of scenario where you're testing. It is literally a phone book this thick of security tests. And the Mobile Application Verification Standard is a way to implement that into a checklist where you know what your application should be doing. It should be doing this, and kind of coming up with security baselines, coming up with a security checklist before you release your apps, making sure that you're doing this and this, and kind of breaking it up into tiers, because guess what? Not all apps are the same. Every app is different. And, we kind of have to come up with an approach that breaks these up into, like certain types of apps all have to do this, and other types of apps have to do this. And, there's standards for every single type of app, so they all have to make sure they're doing that. And that's what MASVS does really well. It really does break those things up. So I really do hope that you get a lot from this talk. I hope you reach out to me if you have any questions. But I'm hoping you have some questions right now. Yep, please.
I have a question. Well, I have a couple of questions. Thanks for the talk. It's pretty interesting. The first one is around authentication. I guess from your experience, what would you say are the biggest? So we've seen, especially recently, there's been exposure of a lot of credentials, how people don't create good enough passwords and things like that. How would you classify like authentication type of issues, like not implementing authentication mechanisms properly? Where does that fit in like mobile application development?
Yeah, so it's funny because I actually think authentication and like session management and authorization, all those concepts are almost exactly the same as they should be implemented in web as they should be implemented in mobile. There really isn't a lot of difference there. That is the one area where I think like, oh, like there's a ton of overlap. Ironically, a lot of apps don't do it the way their web application does it, because I think their thought process is, well, we can get the user in there the quickest, simplest way possible and then have them never be able to sign out, then we've succeeded as an app, which is unfortunate because that means that, they've really left themselves open. There's a couple things I think are the obvious things. Like I recommend checking out, there's actually a whole guide that OWASP has on application authentication and session management called the ASVS. And in general, like good mobile application authentication practices are good web application security authorization best practices. But I think what I'm seeing start to happen, a lot of apps do, is they're starting to use frameworks like, I think, what's that company called? There's an open source framework that you go to that website and it tells you if you've had any breaches on your password or your username, depending on what you have. They actually have an API now that tells you, hey, the password you're entering is in a bunch of breaches. You shouldn't use that password. Or, hey, your account has that password associated with the breach. You probably shouldn't use that password. I think authentication is kind of complicated because I think the best practices from like 10 years ago are now like bad practices today. What our head of our like CISO, I remember when I first started him telling me like, changing rotating passwords, that's a bad practice. Like that leads to a lot of security issues down the line. And when he said that, I was like, what? And then I started seeing NIST come out with documentation about how like, that's a bad practice. Like the more password changes you do, you're just, somebody's storing that somewhere. And then eventually that ends up going into another breach somewhere. And that just causes a ton of other issues down the line. And that was kind of a head scratcher. But yeah, I think, again, I will repeat this again. Good application authentication is good in mobile as it is in web. And the issues I see that are mobile issues would have been solved if they were doing it the same way they were doing it on their website.
Got it. Thanks. Yeah, I have another question, but I'll let other people ask.
Sure.
I have a question. So I'm a web developer, so I don't really know much of mobile, being interested in learning, but I have friends that have done some mobile apps, and usually like you have to get like approved by the Apple Store or like the Google Play Store. Is there anything on like the regulations that you have to check, like some minimum requirements on security that they will check before they approve your app?
So the common things that I'm seeing get apps disapproved are a little bit more on the privacy side related, and not in the way you would think. With Android and iOS, they want application developers to be upfront about what data they're collecting from the app. So a big change that happened a couple years ago was these like use case statements on iOS, where if you were going to ask for permission, like location data or healthcare data or health data or something, you had to give a statement of why you were going to collect that information. And that's been a big one that's gotten some apps rejected. There's some other ones that are a little more hand wavy. For instance, app transport security is a client-side flag in mobile. What does that flag do? It forces the app to only make HTTPS connections. Now, that doesn't mean that those connections are secure in the same sense of the issues we talked about before, but in the sense that, oh, they're only accepting TLS 1.2 connections. So, that backend better support TLS 1.2, otherwise, the app isn't going to make that connection. And there are even cases where it can get around that without changing that configuration. For a while, that was thought to be something that they were going to enforce. They didn't enforce it, but now it's starting to be something where they're like, hey, we think you can do a better configuration. Why don't you update that in the future? But in general, I think both platforms are realizing, well, it's really hard for us to force security on people, but we can do some like privacy enforcement in kind of a more holistic way. And again, that being in the form of telling users what you're doing in the app, telling users why you're declaring this permission, telling users why you need to do this.
Cool. Thank you.
Daniel, you want to bring up your next question?
Sure. Yeah, it's actually related to this privacy thing. So one of the things I've been getting into recently is the concept of differential privacy and how, well, that's kind of like what I want to focus on. But I wrote a short blog recently about data privacy and possibly how the use of edge devices and things like that could help data privacy. But assuming a mobile application keeps your data locally and performs some sort of aggregation and then just sends that to the main server, I guess, where all the fun stuff happens. Do you see that paradigm changing in mobile apps today where they're deciding to keep let's say, the real data and only in the mobile device, and then they only share anonymized data with a central server? Or is this still the case that they're still sending the full data back to the server for analysis?
I think it's complicated because I think when you start thinking about business logic and you think about there's apps that are always going to collect data because it's necessary for them to run. I think, but there are other apps that are doing things to kind of like, I think messaging apps, like secure messaging apps is a perfect example of you have a process that they really want to require, really enforce security at a level where they're not even aware of what their users are sending. And I think you look at apps like Signal and Wicker, and there's some other messaging apps that are really good out there because they're using end-to-end public key encryption. And maybe that's the trick, that things like public key encryption kind of allow the organization to put their hands up and be like, we don't know what's being stored here. We just know that our users are using this app, and our policy is end-to-end encryption. With that said, a lot of organizations are collecting that analytic information for probably nefarious reasons. Some of them not so nefarious. They're actually interested in collecting crash information. Some of these applications, it's necessary for them to share information with third parties to run. And a lot of applications are using, location data to, better serve. And it all comes back to that phrase business logic. It really comes down to there's just unavoidable scenarios where data has to be synced up with the cloud, or data has to be shared between apps, because that's just how the app runs.
Got it. But would it be fair to say that you are not seeing that trend of like more data staying in the device versus going away? Or
It really depends on the industry. That's really what it comes down to.
I'll give you an example. Two of the most popular food chains, fast food chains, have implemented location-based data so that you can log into the application, purchase a sandwich, and it will route that order to the closest fast food chain and direct you to go pick up your order at that location. That data needs to be readily available in order to make that educated decision. So it's a way they're implementing that feature to better serve the customer, but it also could introduce risk by having that data readily available on the device.
Yeah, like I think it's interesting because like I think finance and healthcare are like kind of the leaders in how mobile app security are being is being performed, because they're one of the fewer like areas that are actually regulating themselves and actually trying to be regulated you know, by, you know, federal government. And I think it's interesting because a lot of banking apps don't even store data on the device. It's like, oh, you made a request, here's your information, you logged in. Okay, once you're out, that data is not even going to be stored on the device. So it's almost like the opposite. Like that data isn't even actually being stored on your device anymore. And now it's only coming up when you authenticate to the app and only available to you when you do that. On the flip of that, you know, I work with some organizations that are implementing like health IoT apps. And for them, it's kind of the opposite, where that app data exists on the phone and it's up to you whether you want that to sync up to, you know, the healthcare system's cloud. For some of them that makes sense because, you know, they're journaling health entries and they want to make sure that that information makes sense in the context, you know, of the user's, you know, health. And sometimes they need to share that to a doctor. And you know, that could be used in two ways. But again, that's a case where, you know, they're allowing the user to make that decision. They're allowing the user to make that discretion of who can collect that data and who can't, and when can that data be uploaded and when can't it be uploaded.
got it. Thanks.
So Tony, I can 100% guarantee that everyone on this Zoom meeting has a mobile device and has mobile applications running on it. So maybe what's the most ridiculous thing you've ever found as part of your testing? And if you were to give someone advice who's looking at their phone saying, which one of my applications is leaking my data, is there a story or an industry or a way that we can clean up our devices to be a little less exposed?
I think you're lobbing me a softball here because I think I know what you want me to tell a certain story.
I didn't really, but I'll probably recognize it.
Yeah. I won't name a name, but I will say that the food industry, retail food, is the worst at developing apps. They are having a lot of challenges. There are some organizations that have it figured out really well, but it's a huge challenge for them because when you start thinking about like what food apps actually do, it's like they're trying to be super active. They want to load content right away. They want to show coupons. Users have to be able to log in. They have to be able to place orders through it. So these apps are kind of like at this like precipice of doing a bunch of different things all at once. And one of these popular chain apps had a deal, and you know their popularity was going crazy about how like they were going to give you a coupon if you went to their competitor's place, and then you go back home. And I'm just like, you know what? I'll just take a look at their app because, you know, it's, you know, this was like around like the holiday season a couple years ago. And I was like, you know, we got a little downturn, you know, I got most of my pen testing done, you know, everybody's kind of wheeling in for, you know, the holiday season. And what do I find? But, you know, like some man in the middle issues in the app. And what I found was I could trick people whose connections I was able to man in the middle into either Venmoing me money or doing some other things. Basically, I could stick what's called a deep link into their app. Now, for those of you who don't know what a deep link is, it's just kind of a way to like send somebody to an app or a service or another website or something, and usually with the goal of doing something. And if you're really good at writing them, you can kind of be more specific, like, oh, like go to my website to get coupons, or like, oh, the blah 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 app is out of date, or oh, go here and you can get a $10 gift card. So like all those things are possible. And that was like a perfect example of like, oh, that was bad. But in general, I've seen this across a bunch of these apps, and this was just like the first one where I came across it. Over the years, I've seen a lot of these like popular food brands have a lot of security issues in their apps that really could affect users. And I've generally been nice and just kind of emailed them and been like, hey, I saw this issue. I'm not, going to embarrass anyone. Here's the bug. You should get back to me if you have any questions. But that's like an industry where, and I'm always interested to see like what's the next one going to be, what's the next like where apps like blowing up in, and I know that's going to be where like security flaw galore is going to be, and I kind of have a guess where it's going to be, but I'm not going to say.
Well, don't leave a cliffhanger.
Oh no, I'm going to leave the cliffhanger right there.
Well, I'll say, we've seen a huge uptick in mobile application development in the retail space since March, right? The retail space, where those who were laggards weren't prepared for no one showing up in their brick and mortar stores. It didn't have a mobile app, are rushing to develop something, and we know if you rush to build something and deploy it, there's probably going to be issues. So retail, fast food, also telehealth, right? So in the healthcare space, there's a huge push for telehealth, and we've seen a large uptick in that space as well. And then ironically, I think energy and power generation has gradually been increasing in the last year or two, but shipping and logistics, transportation, shipping and logistics has seen a major uptick. One use case being, hey, I don't want drivers who are meeting with 30, 40 stores a day to be passing paper back and forth and then delivering those receipts back to a warehouse at some point. So contactless, but also GPS and navigation and inventory and supply chain, all of that is moving digital as well. So we've seen a lot of interest and a lot of uptick in mobile applications in that space.
Yeah, it's really interesting. You have this like IT-OT convergence happening, where people who were typically, kind of unconnected are now getting connected, and it's making their jobs easier. And it's creating new challenges for a lot of security teams and organizations, but it's making them run faster. It's making them be better. And we work with a lot of those organizations right now, and it's really interesting to see how it really has changed how they're doing work. And I think like it was just like the first time I heard operational technology. I was like, what's that? I'm like, that sounds interesting. And I'm like OT? I'm like, and I was thinking like, oh, that sounds kind of cool. And then I realized, oh, like that's what OT is? And like, that's what my dad does. He's an electrician at like a factory. Like that's like, what?
Yeah. Well, that's great. Any other questions, feedback?
It's probably really cliche for you guys at this point, but can you tell me if I should make my kids delete TikTok? Is it worse than other apps that treat us like products and violate our privacy?
I think it's worse in a way because it's sending data to China. That's what I think. That's like the big issue.
When we look at network connections, it doesn't directly say data being sent to this server in China. It's typically an AWS server that's been spun up, and then that data is coming from that server to China. So, I mean, it is not a secure app. It is logging data and sharing data to a server in China.
Yeah, it's like any other social media app, right? So it's like, just be careful what you're sharing, and because anything that you're sharing is going to be public somewhere. And if you're on a base somewhere, or you're in the military or something, definitely, I mean, they're already telling you not to use it. It needs to be deleted. And just think as a regular citizen, think about your own what's called OPSEC. What's in the background of that video that your kids or yourself has taken. Can somebody use what's in that background and figure out where you are, and can use that information maliciously, or for worst case, think back when Hawaii had the false incoming missile test alert, right? That ended up being a huge OPSEC issue, because the newspaper or somebody, I forgot who printed it, and the picture that was shown, there was the password in the background on a sticky note on a person's monitor for that system. So, just be careful what you're sharing.
Yeah, I mean, the classic example is like Snapchat. You're like, oh, well, if I take this picture, it gets deleted in 5 seconds. I set the timer. Is it deleted, or is it being stored somewhere? Your friend can't get it or see it twice, but someone has that data somewhere.
So, Tony, you mentioned about just in your off time, submitting bugs to the various different companies, and just say, if you want more information, get back to me, whatever. What's been the most common response? Because you hear about horror stories of companies just going ballistic at people showing the bugs to them that they actually have, even if you have no plans to disclose it.
Yeah, so I rarely do it now, because for the exact reason you described. If I do it, I don't try to be like, this is interesting, because I've gotten kind of like two ends of the spectrum. I haven't really gotten in between, but I've gotten we don't care, and they've shrugged at me, and I'm just like, oh wow. And then I've also gotten should I be worried? Are my developers idiots? What should I do? Do I need to get to them? Just hold up. This is a common mistake. This is a really easy thing to fix. And you get the grateful response too. But I've gotten kind of those two ends. I think I've gotten more of the positive response in general. But especially when I've kind of broken down and described oh, this is why this is an issue. I wouldn't reach out to you if it wasn't a super high risk issue. Again, and usually also talking to the right person is really what matters, I found. If you talk to a help desk, whoever person, they're gonna just be I don't really get this. and or if you talk to a server person about a client side issue, they're gonna be happy because they're well, it's not on my server, it's on their code. and again, totally two different responses. But again, yeah, I think it really comes down to who you're talking to, and being positive, as it sounds hey, you have this issue, it's fixable, you should fix it.
So do you see, there's been an uptick in bug bounty programs? It used to be just like HackerOne. Now, you see bug bounties, a lot of the other large companies and some smaller companies now getting into it. I think, we would agree that that's probably a positive, because then there's maybe a better response coming from a company that does have a bug bounty program in place versus a company that doesn't, and like you said, just shrugs back at you and says, okay.
Yeah, it's interesting, because that's becoming a security requirement for a lot of policy frameworks. where they're saying you should have a, like, something security at blah blah blah.com or .net, and that be where bug bounties be submitted, and having like a process for that. Because the hardest thing that when I used to do that used to be that you would just get kind of like, well, no, you should talk to Bill, no, you should talk to Jim, no, you should talk to Sarah, no, you should talk to this person, and then it would just be like, well, it's not going to get fixed. And I think the idea of like there's an organization that's been kind of talking about that. I think they're called like at security or security at, that are kind of pushing this, like, you should have a email domain that's just your website, security at your website, and that's where your bug bounty program is. That's where you collect that information. And I think it's becoming more positive than it was like 4 years ago. I think it's becoming more accepted, which is good. I think like security research is a taboo for certain organizations, and for other organizations, they're like, yeah, that's cool. Thank you for finding this. And like, we're going to fix this right away. But I've worked at, like in my many years ago life, I worked at organizations that saw like open source software as like the worst thing ever. Like, oh, if you use open source software, there could be bugs in that. and then, but at the same time, they were just like, oh, a patch, this is the worst news ever. We'll get to it in like 6 months from now.
I'll tell you, around bug bounty programs, I work with one of the U.S. largest hotel chains, and one of their top security executives had proposed, we're going to set up this bug bounty program. We're going to implement this bug bounty program. And the team actually collectively got together and came back and said, listen, you want to give a $400,000 reward for a bug bounty, yet you're not willing to spend $100,000 on proactive controls and training to prevent these issues in the first place. You want to give some person that we don't even know $400,000 for finding an issue that we know we have, but we can't find because you haven't given us the tools and the processes to fix ourselves. And it's a really interesting kind of back and forth. And, a lot of organizations, when an executive comes walking down the stairs saying we're implementing a bug bounty program, everyone shakes their head and says, okay, that's what we're doing. And in this particular organization, they came back and said, hey, listen, for a quarter of your bug bounty, I can go buy the tools and the training to get me in a better place. And then once we're all confident that we've, checked our, all the nooks and crannies and checked the doors and windows, and we feel confident, then go run your bug bounty program when we feel really confident that our applications are secure. And I thought that was an interesting perspective when folks are everyone's doing bug bounty, let's do a bug bounty. It's like, well, where could some of those dollars be better spent in training people to build more secure applications from the beginning?
Yeah, and that's something I've heard. Like, I've been in, again, I do a lot of consulting as part of working at NowSecure, and the one thing every security analyst will say is, I hate that we set up this program and we're not, or I've heard CTOs like echo that sentiment that, oh, I hate that we had to pay this out and we could have found it ourselves, because these are the low-hanging fruit things, and they never want to like let up that low-hanging fruit issue get caught by bug bounty, because that means that their security team failed, and that means their security team didn't have the right tools, and their security team just didn't have the time, and that really is the worst case scenario for them.
Just one comment on that. In the company I previously worked at, they did bug bounties before a release. They'll have everybody QA the entire application and actually pay for every bug or issue that you found. And people were more willing to find bugs. And it was, I don't know if it was, sometimes the developers found the bugs, and I was like, oh, so you guys left that on purpose so you could get some money for that later. But yeah, I don't know if that was the case, but it actually proved to be pretty good to have everybody in the organization look for issues, and they did find a lot of issues a lot of
That's
the times.
awesome.
There's some significant advantages of the crowdsourced QA process. I definitely agree with that.
I was just thinking, from the things that I've seen from my end and in my experience is that, a company gets comfortable with its own products to the point that they get blind and they'd start just not seeing the issues because that's what they look at day in and day out. I think that's where the advantages of, when you have auditors coming in and auditing you, one of the best parts of that is the auditor can tell you the issues that you have them and you're just not seeing them, though. It takes somebody from the outside to tell you, hey, you've got this issue.
100%. Another good kind of way to think about that is, when you have a software tool that automates that process compared to a manual testing process, a software tool is going to run the same tests every single time. It runs the complete gamut of tests, where a manual security analyst is, when they get testing application XYZ, the next time that someone sends me that app and says, test this app, they go back to where they found the weaknesses before, and they become inherently biased, as you're saying, Mike, where they only are looking for, did you fix the thing that I found the last time? And they're not looking in every nook and cranny for other issues. So, natural human error and bias of their own products leaves gaps in those controls.
This was a super interesting conversation. This was a lot of good questions and comments. Really, thank you guys for coming and being such experts for us.
Oh, thanks for having us. These are fun. This is This is
a lot of good feedback. We don't normally have such good Q&A after these sessions, so really appreciate you guys having us and joining in on the conversation. We obviously live and breathe, mobile app security, so we love talking about the topic. But Tony's information's here. I can be reached at a similar cthomas@nowsecure if you have any additional questions or feedback for us, or wanted to just get some more information. We have a ton of free resources on our website around best practices for secure mobile development. We have a ton of resources on building privacy into your mobile applications. A lot of free stuff on our website, and we'd love to chat with you further if there's interest.
Fantastic.
You guys both are on our Slack too, so I guess
that's right.
That right?
That's right. Yeah.
Cool.
Well, Zarella's going to do a quick raffle for us and see who the lucky JetBrains product owner is.
Yes. So please stay for just a few more minutes and we're almost done. Okay, let's see. I'm just going to share my entire desktop. Okay, can you guys see it?
Yeah.
Okay. So we have this fun little script. We have the names. Here's the code in case anybody wants to see it. We're just going to run it and see who won the script. So I'm gonna. Okay, oh yeah, I guess I'm ready. This was done by our other co-organizer. Mike, Mike, you got it. I stopped the share.
All right.
Awesome.
You got the JetBrains license. I'm gonna send it to you over Slack.
All right, thank you so much.
Yes, and again, thank you both, Tony and Corey, for being here. We're like happy that you guys are on our Slack officially, so we're happy you're part of our group too. And please stay in touch. Mike, do you have any closing statements?
No, I just want to, again, thank Southwest